Hi, my name is Harley Fuller, and this is my Lab 1 video report. For the agenda today, I will be discussing the problem that we have successfully modeled, showing some of the experiment performed and its results, going through calculations that help explain the reason behind our experimental results, and how we can code a model on computer programming. To introduce this experiment, I will go over the basic goals, materials, and procedure that was used. Our goal is to explore the fundamental physics principle of electric force in charged objects. We will be utilizing basic household objects and creating a charge on them to see how they interact with other neutral, positive, and negatively charged objects. The materials used in this experiment consist of tape, a ruler, a flat surface, and yourself. To begin, I put down a piece of base tape where the next piece of tape will be placed on top. The new tape will be the object that we are giving a charge, and this is done by quickly ripping the tape off of the base tape. To ensure it was done correctly, we must test the charged tape. This is done by hanging the tape off of the side of the flat surface and checking to see if it interacts with our hands. They are neutrally charged. We then can start experimenting with other charges. Next, we create a second charged piece of tape to see how the two charged tapes interact with each other. When the two tapes come close together, they push each other away, which tells us that both pieces of tape have the same charge. In the lab document, we are told we can create a negatively charged pin by rubbing it on a piece of cloth, or more readily available, our own hair. When placing this pin near the charged tape, we see that it also repels. This tells us that the tape is negatively charged because it repels when presented another negative charge. Now that we know the charge of the tape, we can move on to another experiment, which I will show you on the next slide. For this part of the experiment, we will need to add two similarly sized books to our material list. We will take our first charged tape and hang it across the two books. It will need to be hanging down in the center, similar to a rope bridge. This is essential for this part of the experiment, as we will be making the tape appear to float. Since we know that the two pieces of tape have like charges, by the physics property of electric force, they will repel. We will then take our second piece of charged tape and place it near the bottom of the first charged tape. The closer the second tape gets to the first one, the higher the first one will rise, with a noticeable change around 2 centimeters of separation distance. On to the next slide, I will answer a common question about the charges of the objects. The scenario we are presented asks if the charges were reversed, what would change? Well, the short answer is not much. The tapes, for example, would now be positively charged. When interacting with each other, they still have like charges, so they will still repel. Then, interacting with our neutrally charged hand, we know by the physics property of electric interactions with neutral matter that whether an object is positive or negatively charged, it will always attract to another neutral object. Again, no change. For the pin, it now has a positive charge on it. When presented to the positively charged tapes, they also have like charges and will repel. While this is all true, some things that does change is their electric fields. Positive charges exert a force out while negative charges pull in. This would reverse the fields of the tape and the pin in the opposite direction. Now, I would like to show some calculations behind this experiment. On the tape, we know that the two forces acting on it are gravity and the electric force. By Newton's third law, we know that objects in equilibrium have equal and opposite forces. This helps us find the magnitude of the electric force, since we can easily calculate the force from gravity. After using these equations to find the force of gravity, I negated it, as shown in the third point to represent the electric force. This came out to be 0.00175 kilogram meters per second squared. Now, I'm going to move on to another common question. For this question, we must note the fact that it is important not to handle the charged tape too much. This is because when our neutrally charged hands interact with a negatively charged tape, some of the charges transfer over to our hand. This could result in the tape having no net charge and ruining the experiment. On the last part of our agenda, I would like to discuss the coding aspect of this lab. The code I have written takes the length of the tape as an input and gives us back the force due to gravity. With this, I wrote another function using the charge equation to find the total charge on the tape. This involves the position of the two tapes and the force of gravity. This gave me a charge of 5.73 e to the negative 9 coulombs. This concludes my Lab 1 video report. Thank you for watching.